Welcome everyone, I am Paula García. Today we'll explore how brain functioning, neuroplasticity contribute to our learning and cultivating growth mindset. Understanding these concepts can help us create more effective learning experiences for our lives. First, let's look at the frontal lobe. The frontal lobe is essential for higher cognitive function, including problem solving, decision making, planning, and critical thinking. It also plays a key role in controlling attention and behavior. When learning, we use our frontal lobes to engage in tasks that require reasoning, planning, and executing complex ideas. Activities like debates, project-based learning, and strategic games enhance these skills. This aligns with promoting a growth mindset by challenging us to think critically and persist through difficulties. Let's look at the parietal lobe. This lobe processes sensory information and it is involved in spatial orientation and perception. It helps us integrate information from the senses, and it is important for tasks that involve spatial awareness. Incorporating hands-on activities and visual aids and integrating physical movement helps us understand abstract concepts better. By doing so, we stimulate all sensory channels and encourage ourselves to see challenges as opportunities to grow. The temporal lobe is crucial for processing auditory information, and it is involved in memory, emotion, and language comprehension. It is essential for listening, understanding language, and memory formation. To engage the temporal lobe, we could use auditory learning tools like storytelling, discussions, and activities that promote memory retention through repetition and mnemonic devices. This approach supports a growth mindset by reinforcing that effort and practice improves skills. Now, the occipital lobe is primarily responsible for visual processing. It enables us to interpret information critical for reading, recognizing patterns, and visual learning. The use of visual aids, diagrams, videos, and written instructions enhances comprehension. This variety helps us realize that we can understand complex information through different methods, reinforcing the idea that abilities can be developed. Lastly, the limbic system, a system that is a complex set of brain structures that plays a crucial role in learning and emotional regulation. It includes key components like the hippocampus, amygdala, thalamus, and hypothalamus. The hippocampus is vital for forming and retrieving memories, which are essential for learning processes. The amygdala is involved in processing emotions, particularly fear and pleasure, and plays significant roles in emotional responses and emotional learning. Together, these structures work in concert to manage how emotions influence learning and interactions, enabling us to form emotional memories and adapt our behaviors based on past experiences. Now, let's discuss neuroplasticity, the brain's remarkable ability to adapt and reorganize. Neuroplasticity is the scientific basis for the growth mindset, the belief that intelligence and talents are not fixed but can be developed with effort and persistence. In other words, this means that every interaction, every lesson has the potential to shape the structure and function of our brains. Let's reflect on the widespread misconception about brain function and learning processes that often arise from misunderstanding or oversimplification of neuroscientific research. These are called neuromyths. These ideas are widespread. Common examples include the belief that individuals are either left-brained or right-brained, each hemisphere controlling different cognitive functions, or the idea that people have distinct learning styles such as the visual, auditory, or kinesthetic, which should be addressed for effective learning. Another pervasive neuromyth is the assertion that we only use 10% of our brains, suggesting a vast untapped potential. These myths persist despite being debunked by scientific evidence, often because they provide simplistic explanations for cognitive phenomena. The perpetuation of neuromyths can significantly hinder both teaching and learning by promoting ineffective educational strategies and diverting attention from evidence-based practices. For instance, teaching students according to the learning styles can lead educators to ignore more effective research support methods, such as spaced repetition or active learning techniques. Additionally, believing in neuromyths can foster a fixed mindset among people, where we may feel limited by our supposed brain dominance or learning styles, rather than encouraged to develop a broad range of skills and strategies. This not only impedes individual academic growth, but also affects overall educational outcomes. To critically reflect on neuromyths and inform decisions in our learning, we should engage in continuous professional development that emphasizes current neuroscientific research and evidence-based practices. This involves scrutinizing popular educational claims, seeking out reliable sources of information, and fostering a culture of skepticism and inquiry. Collaborating with colleagues to share insights and challenge unfounded beliefs while also incorporating critical thinking exercises into our daily lives helps us become more discerning consumers of information. By understanding the functions of our brain and neuroplasticity, we can create more effective and engaging learning experiences. Emphasizing a growth mindset helps us embrace challenges, persist in the face of setbacks, and see effort as a path to mastery. Thank you for joining us for this introductory exploration of neuroplasticity. Let's unlock the full potential of our brains to foster a love for lifelong learning.